Well, let's take a look at Friedel alkylations. So we'll start off with a very simple reaction. We got benzene here and chloroethane, ethyl chloride. What we need, of course, is our Lewis acid catalyst. So we go to the reagents chart here in Oscarson, grab some aluminum chloride, stick it, it comes down under the arrow. This is going to serve as the catalyst. Press the button. What do we get? Well, of course, Oscar knows what he's doing. We get ethyl chloride. So let's just make it a little bit more complicated. Let's add another methyl group. So I erase this product, add another methyl group. Now we have propyl chloride. We're supposed to get and propyl benzene. Push the magic button. What do we get? We don't get N-propyl benzene. What do we get? We get isopropyl benzene. This, of course, is the result of a rearrangement. I was setting you up. So how do we explain this? Well, for this, let us go to get out of Oscarson, go to Oscar Sketch Plus. I'm going to go home. I'm going to go over to Oscar Sketch Plus. I've got it all. I want me to load up a different version here. I got preloaded this. So here's our aluminum trichloride catalyst, all set up with the propyl chloride. So what's our first step going to be here? Well, our first step is going to be the association of the propyl chloride with the aluminum. So I just want one simple arrow from the chloride here down to the aluminum. This is just showing that you get a Lewis acid base complex between the propyl chloride and the aluminum. And use Wolfie's arrow here, and here's our complex. Let me just bring this up here and make it a little bit smaller, or we're going to run out of room. So now this complex is ready to fall apart. In essence, what happens is it's going to pull the chloride right off the propyl group. But if we did that directly, of course, what we would get, and I could draw the arrows for it. We draw this arrow here. We're going to go off. We'll be left with a primary carbocation, and primary carbocations is not something you want. So how we get rid of that, get away with that, is, of course, we recognize we have the two hydrogens over here on this middle carbon. And one of those hydrogens is going to move as a hydride to that primary carbon and give you a secondary carbocation. So let me click here, and so here's our secondary carbocation and our aluminum tetrachloral and aluminate. Let me now complete the reaction. Of course, we need our benzene. And bring a benzene over here. Okay, and we're simply going to now have the benzene attack the secondary carbocation. And this gives us our, move down here a little bit, this gives us our rhenium ion. The rhenium ion has to lose its proton. So here's the proton that has to be lost. What are we going to do for a base for that? Well, you can just kick it out, but it's more realistic to come and use our aluminum complex up here, duplicate that one, bring it down here, and agree. Now what's going to happen is simply we'll take one of these bonds, come over, grab the proton, take the protons, electrons, restore the double bond, and there's our mechanism. So these rearrangements will occur whenever you would be getting a primary carbocation. So these things show you one of the big problems with Friedel alkylation. You can't make primary carbocations. It just isn't going to work at all. So that's kind of interesting. But while we're here, why don't we go ahead and go back and look at a more complicated example. So I want to go back to Oscarson now. And let's just draw something a little bit more fun. So I'm going to get rid of this guy, and let's do an intramolecular example. So I'll do 1, 2, 3, 4. Here I'm going to put on a chloride. Okay, so what in the world is this going to give? What do you suppose? So what does it give? Oscar's thinking, look at this. We just did a cyclization with a rearrangement. So you see what happened? It's the same thing. The aluminum trichloride, we want to pull off that chloride. It would make a primary carbocation, which would, of course, not be stable. So instead, as that chloride is being pulled off, you have a hydride shift from the cis position, and then this secondary carbocation cyclizes around into the double bond to make the final product. So you can do lots of really weird things with these alkylations. And it doesn't have to just be aluminum trichloride and a chloride. Any other way of producing a carbocation can also lead to Friedel-Crafts alkylation.